Okay, let's look at question number 11, part A of 2025 Western Province third term pure mathematics paper. Right, so this is the quadratic question. Right, so let's look at what is given to us. C is a positive real number and we are given this quadratic 2x squared minus 6 plus c cube is equal to 0, and we are also given roots are real. So that is also given to us. Right, if the roots are real, we have to show c is in this interval 0 to 1 over n, and n is a positive integer that we have to find. Right, we'll first do that part. So roots are real is what we have to use. So roots are real mean discriminant has to be greater than or equal to 0. So that means b squared minus 4ac has to be greater than or equal to 0. So what is b? B is minus 1. So minus 1 squared minus 4 into a, which is 2, into c, which is c cube, has to be greater than or equal to 0. So 1 minus 8c cube has to be greater than or equal to 0. So this is same as 8c cube minus 1 is less than or equal to 0. Right. Okay. So then can make this into what? Let me 8c cube is same as 2c cube. 1 can be written as 1 cube. So this is a difference of cubes, no? So we'll use the formula 2c minus 1 times 4c squared plus 2c plus 1 has to be less than or equal to 0. Now we have to find the interval. Now let me complete the square for this one and show that that is always positive. Complete the square. If I complete the square, I get 2c plus half whole thing squared plus 3 over 4. So this is always greater than or equal to 3 over 4. No? So this is positive. So this second bracket is always positive. So then the only way this whole expression can be negative is if 2c minus 1 has to be less than or equal to 0. So then c has to be less than or equal to half. But we started with this, right? C has to be also real and positive. So C has to be also positive. So then the interval is what? C belongs to greater than 0, less than or equal to half. So square bracket here. So n is 2. The positive integer that we were looking for is 2. N equals 2. right? So that part is done. So that's the first part. Then what are we supposed to show? Then they are saying the roots, take them to be this: alpha 1 over n plus 1 and beta 1 over n plus 1. So that means n is 2, no? So let's write down those. So the roots are alpha 1, alpha 1/3 and beta raised to 1/3, right? So those are our roots, right? Now let's go back to the question. Then we have to write expressions for alpha plus beta and alpha beta in terms of C, right? So we have to write this alpha plus beta and alpha beta in terms of C. So let me first write the two expressions for alpha raised to 1/3 plus beta raised to 1/3. That is going to be what? From our original quadratic, these two are roots of the original, so minus b over a. So that is minus 1 over 2 minus 1 over 2. So half. This is half. And the product of the roots is what? Product of the roots is c over a. So c cube over 2. So c cube over 2. Right. So this means alpha beta to 1/3 is c cube over 2. So we can easily find alpha beta. So raise both sides to third power. So alpha beta is c to the 9 over 8, right? So one part is done. Now we need to find alpha plus beta, right? Alpha plus beta. So we'll do it like this. We know this. This is equal to half. This is equal to half. So let me take the cube of this. Then using the binomial expansion, you can write what? Alpha 3 alpha raised to 2/3 beta 1/3 plus 3 alpha raised to 1/3 beta raised to 2/3 plus beta. So this side is half cube. This side, let me group alpha plus beta, and from these two terms take the common part out, group them, factor it. So you can take 3 alpha 1/3 beta 1/3 and you are left with alpha 1/3 plus beta raised to 1/3 inside, right? So then 1 over 8 alpha plus beta 3 times this one is c cube over 2 and this one is half, right? So then alpha plus beta is what? Alpha plus beta is 1 over 8 minus 3c cube over 4 or 1 minus 6c cube over 8, right? So then those are the two expressions we needed. So alpha beta is c to the 9th over 8 and alpha plus beta is 1 minus 6c cube over 8, right? So That part is done. Now let's see what's the next part of the question. Right. Okay, after that we have to find the quadratic with roots alpha and beta and show that that is equal to this, right? Okay. So that's what we'll use the equation x squared minus sum of the roots plus product equals 0. That is the quadratic equation formed. So then alpha plus beta, the roots are alpha and beta, no? So this plus alpha beta, that's the expression we are looking for, and we found this. So what is alpha plus beta? This one, 1 minus 6c cube over 8. So let's put that 1 minus 6c cube over 8x plus alpha beta, which is this one, c to the 9 over 8 equals 0. Multiply by 8, so 8x squared minus 1 minus 6c cube x plus c9, c to the 9. Is that what we want? We want plus in the middle, so right, take the minus sign out here. So 8x squared plus 6c cube minus 1x plus c to the 9 equals 0. So that is the quadratic we wanted, right? So we created that. This is the quadratic with roots alpha and beta, right? What is the next part? Right, now they have given that take fx to be this, and fx x intercept is minus. So they have given fx x intercept is minus. So what does that mean? Okay, so let's write down fx x to the 9 plus 6x cube plus 7 plus 6x cube plus 7 x intercept is negative. So that is given to us. So what does this imply? We can use this. So how do you find the x intercept? You substitute y equals 0 or equal the function to 0. So then when we equal this to 0, we get x value, no? The solution x is, that solution is going to be, x intercept is going to be negative. So we'll get x equals some negative number. Okay, so we have to use that. So the root is going to be negative according to what is given to us, right? So then using that we have to show what? So that is given. Now we have to show 1 is not a root of the quadratic that we created. So what's the quadratic we created? This one, right? So let me give that quadratic a name, g of x. So 8x squared plus 6c cube minus 1 x plus c to the 9. So we want to show x equals 1 is not a root of g of x. So I will substitute 1, g of 1. So what's the expression I am going to get? 8 plus 6c cube minus 1 plus c to the 9. So that is same as c to the 9 plus 6c cube plus 7, right? If this is a root, this expression has to be equal to 0. Can this expression be equal to 0? So now we come back to here. If this expression is 0, this is the same type of expression with a different variable. So from what is given to us, this expression can be 0 for c equals negative value. But what is given to us? We started the question with c is a positive value. So there is no c value that will make this expression equal to 0. So this one, c to the 9 6c cube plus 7 will never be equal to 0 in the given c values. So c is positive, no? So this will never happen. So that means g of 1 is not equal to 0. So that means x equals 1 is not a root of g of x, which is the quadratic, right? So that part is also done, right? So next, what do we need to show? Right, after we showed that, we need to deduce. So use this quadratic to get the new quadratic with these roots. So we want to find the quadratic with roots alpha over 1 minus alpha and beta over 1 minus beta. Use this quadratic to do that. So let me write the original quadratic that we have here. 8x squared plus 6c cube minus 1x plus c to the 9 equals 0. So this one has what roots? X equals alpha and x equals beta, right? We want to create one with these roots. Let's take the roots as what are the roots we want? Alpha over 1 minus alpha and beta over 1 minus beta. So we want to create the quadratic with these roots. Alpha, y equals alpha over 1 minus alpha and y equals beta over 1 minus beta, right? So then we need a expression for y in terms of, sorry, we need expression for x in terms of y. So we are taking these are the roots, no? So when x equals alpha, y can be written as what? Y can be written as x over 1 minus x. So cross multiply y 1 minus x equals x. So that means y minus yx x x plus 1. So no, wrong, that's wrong. Move yx to that side. Y, you can take x out, y plus 1, right? So then x equals y over y plus 1. You can show the same thing when x equals beta. Y equals beta over 1 minus beta. Then y equals what? X over 1 minus x. So then same process, x equals y over y plus 1. Right, so now let's substitute this into, let me give this a name, to star. Sub x equals y over y plus 1 into star, right? So then 8 y over y plus 1 whole thing squared plus 6c cube minus 1 y over y plus 1 plus c to the 9 equals 0. So this gives you 8y squared y plus 1 squared plus 6c cube minus 1 y plus 1 plus c to the 9. So multiply everything by y plus 1 squared. So 8y squared plus 6c cube minus 1 y into y plus 1 plus c to the 9 y plus 1 whole thing squared. So then expand and group the terms. 6c cube minus 1 y squared 6c cube minus 1 y. Here we have c to the 9 y squared 2c to the 9 y plus c to the 9 equals 0. Now group the terms. So I can group y squared c to the 9 6c cube minus 1 plus 8 y squared, and the y terms 6c cube minus 1 plus 2c to the 9 y and c to the 9, the constant term. Now simplify. So I get c to the 9 6c cube plus 7 y squared plus 2c to the 9 plus 6c cube minus 1 y plus c to the 9 equals 0. Let's see if that is what we want. Right. That is what we want. So that is the quadratic with roots alpha over 1 minus alpha and beta over 1 minus beta. So that's the first part of question number 11. Next we'll look at part B.